Okay, so on page 3, we're going to do number 3 together in class. I'm going to skip that now. At number 4, this is a good multiple choice type of question or an explanation. In recent years, they actually like to ask this as an explanation type of question. Alright, so you need to be able to explain this in words and formulas, and I'll show you where you get your marks. It asks, a vehicle hits a tree, in front of the car crumbles a 1.5 meter until it comes to a stop. Okay, so you've seen that before in your life, right? Explain what is better for the driver if the front end of the car crumbles during the collision by referring to a relevant formula. Okay, now that there, by referring to a relevant formula, or they'll say by referring to a law or a concept or whatever. Okay, so you have to write down the formula. You get a mark for that. Now, what happens if a car crumbles, or when you jump and you bend your knees, or what else does this happen? When you catch a ball and you take your hands back, so you catch a ball and your hands go back, and I'll explain this in the class again so that you'll see it. So what happens then is, what you do is you extend the time so that the force is not that great. Okay, so I've mentioned force and I've mentioned time. So that is why we use the impulse formula. So you're going to write the impulse formula, F delta T is equal to delta P. Now, why would they ask, what's better for the driver if the front end crumbles? They can basically ask, why is the force better for the driver? Okay, so we want to rearrange this formula so that it gives us force. So force, is equal to the change in momentum over the change in time. And this is where we will refer to Newton's second law, or why I referred to Newton's second law in the previous video. So if we want to look at why it's better, why is the force better, we have to consider both things here. If we look at both things, force is directly proportional to delta P. So because it's at the top, it's directly proportional. Now, what is delta P? Delta P is mass, final minus initial velocity. Now, when the car started to drive here, let's say the velocity was 100. Okay? When it stops here, the velocity is 0. Now, if it takes an hour to stop, or if it takes 1 second to stop, the initial velocity will still be 100 and the final velocity will still be 0. So that does not change. When the car crashes, okay, the mass stays the same. So before the crash and just when the crash happens, the mass stays the same. Maybe after the crash something falls off, but when the crash happens, that moment, that split second when it happens, the mass stays the same. So this whole concept does not change if it takes an hour to crash or if it takes a split second to crash. That stays the same. So with that, you can say delta P remains constant. Okay, so it has no effect on the force. Then if we look at the time, if we look at the time, we see that time is at the bottom. So the force is inversely proportional to the time. What does that mean? It means if the time increases, the force decreases. So if the time increases, the force will decrease. They're inversely proportional to one another. Okay, so when this crumbles, it means the car takes longer to come to a stop. If it just whoosh and it doesn't crumble like that and it just stops, then it's a split second. But if it crumbles, then it takes maybe 5 seconds. Or when you bend your knees, when you jump, you increase the time that it comes to a stop. So it takes longer to stop. If you just keep your knees straight, then you'll immediately come to stop, but it will be very tough on your knees. Okay, so they are inversely proportional to each other, meaning when the car crumbles, it means the time increases. And because time is inversely proportional to force, that means that the force decreases. So it's better for the driver if it takes longer to come to a stop. But I'll explain this again and we're going to do that in exam questions as well. All right, then we're going to get to the second last concept here. What is an isolated system? Definition there, an isolated system is one in which the net external forces acting on the system is zero. Okay, so it means there's no external forces, or the net external forces cancel out, or yeah, we can say there's no friction. Almost in brackets you can tell yourself that there's no friction or air resistance or applied force or anything like that. Right, another word for isolated system, is a closed system, but they do not like it if you use the word closed system, or they don't want you to use it. Rather use an isolated system. Okay, then what is the conservation of linear momentum? Now, conservation means keep, almost like keep constant in your head. No? Don't change it, keep constant, conserve something, don't make it less. So conservation of a linear mean in a straight line momentum. All right, now what is that? The definition. The total linear momentum. Now total means you must add it. The total linear momentum of an isolated system remains constant or remains conserved. Okay, so that means the sum. Okay, so now that symbol there is the word sigma, and that means the sum of. Okay, so we pronounce it, the sum of the momentum at the beginning is equal to the sum of the momentum at the end. Now, when do we use that? We use this, the conservation of a linear momentum, when we have an collision. Okay, so when two things collide, so when you have a car crash, or you play bumper cars, or something like that. And this is what your practical for this term will be all about. Sorry, that is my sparkling water. So that is what your practical is also, or will also be all about. Okay, is this when we're going to let two trolleys crash, and we're going to see if the momentum will be conserved. Sorry, my throat was a bit sore. Okay, so we're going to look at closed systems or isolated systems, and we're going to look if the total linear momentum is conserved. Okay, and then I just remind you, remember, it is a vector momentum, so you need to choose a positive direction. Okay, so it says the ball of mass 25 kilograms travels to the right with the velocity of that. It collides with ball of that of so much, that must be 10 kilograms. Also moving to the right with the velocity of that. After the collision, the ball is the velocity of that, and what is the velocity of the 10 kilogram ball? Okay, so this is what I did here. Right, so you have two balls with different masses, and they both move to the right with certain velocities. And then because this one is traveling faster than this one, they collide with one another, and then they will both be traveling to the right still, and we want to know what is the second velocity. All right, so because you hear the word collision, you immediately know we're going to go to the law of conservation of linear momentum, which is the sum of the momentum at the beginning is equal to the sum of the momentum at the end. Okay, now we have two objects before, and we have two objects after. Right, so you are going to say, and I want you to actually put in another line there. So we have mass times velocity of the 25 plus mass times velocity of the 10. So those two beforehand, initially, equals to the mass times velocity of the 25 plus mass times velocity of the 10 afterwards. All right, now we're going to fill in our values. The mass is 25 at the beginning, and the velocity is 20. Sorry, what I forgot to do, they are both moving to the right. So I'm going to choose to the right to be positive. Okay, so that's positive 20 plus the mass is 10 and the velocity is 10, so positive 10 equals 2. the mass here is 25 again, and the velocity is 15, plus the mass is 10, and I want to know what is the final velocity of that one there. Okay, so when we calculate that, and I apologize, I do not have my memo with me, so that is why I'm typing this in as I go. Okay, so I'm just going to do this quite slow now. So this here is 600, and on the right hand side we have 375 plus 10VF. So you're going to take this to the other side, you're going to subtract it to the other side and subtract it, and then you're going to divide by 10. And I got the final velocity to be 22.50 meters per second. And because my answer is positive, and because I chose to the right to be positive, I'm going to say this is to the right. And this is very important that you do state the direction, because you get a mark for stating that. So this will count 4 marks or 5 marks. So you'll get a mark for writing either one of those two correct. Values, answer, and direction. 5 marks. Okay, let's look at another one. It says, an object of mass 2 kg travels right at 10 meters per second. It collides head on. Now that's a clue that they moved in opposite directions. So we have to be very careful that we choose a positive direction and that we stick with it and use it. Head on with an object of mass 4 kilograms moving to the left of that. The two stick together on impact. Calculate the velocity after the collision. Alright, so you can see here we have 2 traveling at 10, 4 traveling at 20 in opposite directions. Then they collide with one another. They stick together afterwards, and we don't know in which direction they will be moving, but we need to calculate the velocity. Okay, now because this one has a bigger mass and a bigger velocity, it will have a bigger momentum. So I'm going to choose to the left to be positive. Okay, so I'm stating clearly there to the left is positive because there's a collision. I know I have to use a conservation of linear momentum. That is my clue. Collision, conservation of linear momentum. So we have the momentum at the beginning is equal to the momentum at the end. Okay, so we have at the beginning 2 objects plus that is equal to, and afterwards they stick together. So it's the mass of that and the velocity of that of 2 plus 4. Okay, sorry, that is initially, that is final. Okay, so the mass is 2 and the velocity is 10. Careful. Why careful? I chose to the left to be positive, and this one is moving to the right, so that must be -10. Plus the mass is 4 and the velocity is 20. The mass afterwards is going to be 2 plus 4. How did I get that? They stick together, so it's 2 plus 4. And I do not know what the final velocity will be. I need to calculate that. So on the left-hand side, I have 60. And here I have 6 final velocity. And I have the final velocity is thus 10 meters per second. Alright, and because I get a positive answer and because I chose to the left to be positive, this is thus to the left. Okay, last one there. A bullet of mass so much is fired at so much. Determine the recoil. Now, if you shoot with a gun, and I don't know who of you have ever shot with a gun, then the gun kicks back on your shoulder. As you shoot with it, a big gun kicks back on your shoulder. So there's like a big force or a push back on you. Determine the recoil velocity of the gun if the gun has a mass of so much. Okay, so what happens here is the bullet is inside the gun, and then push goes the where you fire the gun, and then the bullet goes out. There goes the bullet, and they tell us the velocity is 280. And then the gun pushes back with a force on your shoulder. Right. Now we need, because there's a collision, because they shoot with it, we know it's the law of conservation of linear momentum. So at the beginning, the bullet is inside the gun, so it's considered one thing. So at the beginning, the mass, we can add them together. The gun is 7 kilograms and the bullet is 0.05 kilograms. And at the beginning, the velocity is 0 because it's stationary. We haven't shot the bullet yet, so they're not moving. Here we know the final velocity there is 280 and it's moving to the right. And that is now of the bullet. The final velocity of the gun we do not know. And the mass is still 7.05. No. Sorry. This mass is 0.05 and the mass of the gun is 7. Okay, so at the beginning we have one object because they are together. So that is of the gun and the bullet initially. And then afterwards we have the velocity of the gun plus the mass times the velocity of the bullet. So that is final. Right, let's put in our values. The mass at the beginning is 7 plus 0.05. And the velocity at the beginning is 0. The mass of the gun is 7. And the velocity of the gun we do not know. Plus the mass of the bullet is 0.05. What did I forget to do? I didn't choose direction to be positive. Okay, so I'm going to choose, because the bullet is moving at a massive speed, I'm going to choose to the right to be positive, the direction of the bullet. So that is thus 280. Okay, positive 280. Now, when you calculate that, remember that together is 0, because anything times 0 is 0. And we have 7, the velocity of the gun, plus 14, and when you take it to the other side, it becomes negative 14, and thus the velocity is negative 2. Now remember, you can't leave your answer in the negative, so it means it's 2 meters per second. And we chose to the right to be positive, so that means it is to the left. And does that make sense to us? Yes, it does, because as you shoot the bullet, the gun recoils back. So to the left does make sense to us. All right, so I'm going to do the next concept with you hopefully in class on Wednesday. What I want you to do for homework then with that is question 4 and question 5 and question 6 and question 7. Okay, 4, 5, 6 and 7. Good luck.